friends, welcome to Arnav. So today it is the 50th episode in the science series. So in the last episode of the physics, so we discussed about simple machines. So by the way, it is physics today in the science series. So today we are going to discuss about levers. So levers are also a type of simple machines. So let's get into them. So lever is a bar that tilts on a fulcrum / also called as a pivot. Yes. So a lever is a bar. So first we take a bar. So it tilts on a fulcrum or like a pivot. So like a seesaw example. So first there's a bar on it. Then under that there is a pivot, which is in these terms called as a fulcrum. Yes. So then if you push here, that side will go up, and if you push here, that side will go up. So if you apply force / effort to one part of a lever, the lever swings on the fulcrum to raise another part called the load, which has the load on top of it. Yes. So first in a lever, in classifying levers, there are three objects that classify a lever by where they are placed. Yes. So here these are all the three types of levers. So in these objects are placed in different places. So first the effort is the force that the person applies. So next the load is the object that is put on the lever, and the fulcrum is the before mentioned pivot. Yes. So the lever works in three ways depending on the relative positions of the fulcrum, load and effort on top of the bar. So here it is on top of the bar, or at least under the bar too. Yes. So next the types of levers. So yeah, let's start. So I also have some examples with me. So first are the first class levers. So the fulcrum is in between the effort and the load, as in a beam scale or a pair of scissors. So here is the load and here is the fulcrum as well as the effort on the other side. So two levers are hinged at a fulcrum. Yes. So two things are on the opposite side of them, like the forces. So load and effort are equal because the distance between them and the fulcrum is also equal to. Yes. So here let's take an example. So here when we do like this, we are putting effort on this side. Next here both of the beams are connected. So that is the fulcrum. And finally here we put the paper or any other thing that is going to be cut. So that is the load side. Yes. So that explains the scissors as well as the first class levers. So again there are two other types of levers. So next are the second class levers. So for this we are going to take the lemon squeezers. Let's squeeze the lemon squeeze. So the fulcrum is at one end. So while the effort is applied to the other end here. Yes. So there is a load between both the fulcrum and the effort. So this is like in a wheelbarrow or a pair of nutcrackers or even a pair of lemon squeezers. Yes. So the effort is twice as far from the fulcrum as the load. So the force needed to lift it is halved. So for example, if this is like a real life seesaw like thing, so if we push from this effort side, then the load will be a bit less higher than so yeah, we need to push more for it to become more higher. So yeah, like if we push 2 meters high, then this would like push 1 meter high, just 1 meter. Yes. So an example is the lemon squeezer. So see this. So first the fulcrum is this side where the beams both are connected. Next the load / the lemon or the orange, any citrus fruit is applied here. And finally we put the effort here, apply it there. Yes. So and finally the last type of levers, the third class of levers. Yes, so there are three types of levers. So the fulcrum is at the end point here too. So with the load at the other end and effort applied in between, as in a hammer or a pair of tweezers slash tongs. So this is just like the second class levers, but the places of the load and effort are reversed. Yes, they just change places. So the load moves twice as far as the effort because it is twice as far from the fulcrum. So this time if we just push it down from here, then if you push 1 meter up from here, in this load will get 2 meters high. Yes, so these third class levers are a bit more effective if you want to push something higher. Yes. So next let's explain the tongues, how they are third class levers. So first here is the fulcrum where they are kind of connected. Next here we apply the effort, and finally here we put something and like the marker. Here the marker is the load. So this is how a tongue works, a tongue slash pair of tweezers. So I even showed all of them with examples. So this is for today about the lever, which is a simple machine. Bye.